Hey grade 10s, I'm just making a video lesson here, just going over some of the more complex concepts in properties of exponential functions. I'm going to focus mainly on the transformations of exponential functions. I think this is where it starts getting a little bit more difficult. So again, I apologize that I can't go through the whole lesson, but I'm just going to try to focus on the tougher examples in the lesson. Before we get to the transformation of exponential functions, I want to focus on the general characteristics of exponential functions of the form y is equal to b to the x. The first thing I hope everyone notices is that the base here will have to be greater than 0. If it's actually less than 0, that's a bit more complex. We're just going to focus on when the base is greater than 0. And we notice that in this case, in exponential functions, the variable is in the exponent. And this is why it's called an exponential function. So here's a summary of all the properties of exponential functions that are of this form. So we know that the domain is going to be XCR, so you'll be able to sub in anything into the function. You always have an answer. And we already know that we can have negative exponents as well. So I can have negative exponents, positive exponents, rational exponents, anything is possible in terms of what I can sub into my exponential function. Now the range is more limited, so we notice that the range is greater than 0. And I hope that this kind of makes sense. If we look at an example, let's say we have y is equal to 4 to the x. I can sub in positive exponents, negative exponents, fractional exponents, doesn't matter what I have. But what I always notice is that my answer will have to be greater than 0. I cannot have a power that is negative. So in this case, whenever we have b to the power of x, we're always going to notice that the power itself will be greater than 0. We also notice that if the b value is greater than 1, then the function will be increasing. We can look at the same function here as an example. If we have y is equal to 4 to the x, that means that we're multiplying by the outputs by 4 each time, which means that it is obviously increasing the whole time, which means it is a growth. And if b is between 0 and 1, so let's say we have something like y is equal to a half to the power of x, that means that the values are getting smaller and smaller each time because we are multiplying by half, which means that the values keep decreasing. So this is an example of something called decay. The y-intercept will always be 1 when we have exponential functions in the form of y is equal to b to the x. And of course, we notice that we have a horizontal asymptote on the x-axis, which means that the horizontal asymptote is y is equal to 0. And remember, horizontal asymptote is a point that we keep getting closer and closer to, but we never actually reach. So what happens if we start transforming this exponential function? Well, luckily, a lot of the transformations that we apply to parabola, square roots, and absolute functions will be the same for exponential functions. The one big difference that we notice is that we do not have just one parent function, we actually have multiple parent functions. So essentially what we notice is that if we start adding on the a, k, d, and c variables in the exponential equation, we will start transforming our graph. And we transform the graph base function, which is b to the x. Luckily, the variables a, k, c, and d will transform our parent function in the same way that they did for parabola, square roots, and absolute functions. So as long as you remember how the graph is changed by those variables, it works the exact same way here. This table here summarizes the 4 variables and the effect that it has on the base function. So now let's look at an example. Suppose that we are given this exponential equation and we want to find out what the transformation looks like. So the first thing I would do is I would compare it to a general transformation. So we have a b to the power of k, and then in brackets x minus d plus c. So we should be comparing the variables in this equation with the variables in the general transformation. The first thing we notice is that the base function can be found by looking at where the exponent is in the transformation and looking at just what its corresponding base is. So in this case, we have an exponent of negative 4x plus 8, and the base in this case is the 2. So that makes sense that our base function will actually be y is equal to 2 to the x, because our 2 is our base here. So this is going to be our base function. It's going to be 2 to the power of x. The next thing we should focus on is the exponent. We notice that the exponent here is negative 4x plus 8, and negative 4x plus 8 doesn't quite look like k and then in brackets x minus d. So the first thing we notice is that we should probably factor this. So let's factor this out. So we have negative 4 and then in brackets x minus 2. Now this exponent right here looks like it does in the original transformation. So to make this more clear, I'm going to rewrite f at x as 3 and then in brackets multiplied by 2 to the power of negative 4x minus 2 and subtract 1. Now that we have rewritten the exponential function, I hope it is more clear what the a, k, d, and c variables are. So we first notice that our leading coefficient is 3, so that means that a is equal to 3, so this graph will be vertically stretched by a factor of 3. And next we notice that the k value is negative 4, so since k is equal to negative 4, that means that we reflect on the y-axis, and the graph has been horizontally compressed by a factor of 1 over 4. So just remember that we have to take the reciprocal to find the factor there. Next, we look at our d value, and we notice that our d value is 2. So d is equal to 2, which means that we have moved the graph from 2 to the x in this position here 2 units to the right. And finally, our c value is negative 1, which means that we are going to be moving our graph 1 unit down. So now that we have our 4 transformations listed out, we know that all these transformations will be applied to the graph of 2 to the x. So keep in mind that if the base here had been 4 to the x, then we would be applying the transformations to 4 to the x. If the base here was 6, then we would be applying all these transformations to 6 to the power of x. Now let's look at the y-intercept and horizontal asymptote. So to find the y-intercept of an exponential function, it's quite easy. All we're going to do is let x equal 0, and then we solve for y or f at x. So that's pretty simple, just like we did before. To find the horizontal asymptote, this is the one that's a little bit more tricky. We have to really analyze what happens in general with exponential functions. So we already learned that b to the power of x will always be greater than 0 when b is greater than 0. And this is always going to be the case in exponential functions. So even if I had a different k or d value, my value will always be positive, and if we just consider this power here. Well, what happens if I multiply this power by a? Well, there's two options. If a itself is greater than 0, then that means that this whole entire value here will be greater than 0. But if a is less than 0, then the whole entire power here will be less than 0. So what we notice is that we only have two options. This power is either completely above 0 or completely below 0. So we already noticed something very important. The k and the d value didn't have any effect at all. So the only two variables that affected the most are the a and c value. And a doesn't really affect it as much. We're really just noticing whether it is above or below the horizontal asymptote. But your key here is to know what the c variable is, because this will determine the horizontal asymptote. So we only really need to look at the c value to know what the horizontal asymptote is. So our conclusion here, the horizontal asymptote is y is equal to c. And knowing whether the a variable is positive or negative will simply tell us if it is above the horizontal asymptote or below the horizontal asymptote. Let's look at one last example here. So we're given this exponential function, and we are asked to find the base function, the transformations, the y-intercept, and the horizontal asymptote, and then finally to sketch the graph. Just for time's sake, I'm not going to do the very last one there. I'm just going to focus on a to d here. So first thing, the base function, we can easily find that by looking for the power itself and what the base is. So we notice that this is going to be our power, and the base in this case is 4. So because 4 is the base, that means that our base function is y is equal to 4 to the x. So this is going to be the function that we are going to transform. Our next step is to identify what the transformations are. So to identify the transformations, we first need to make sure that it is written in the correct form. That means that the exponent needs to be factored out properly. So we have y is equal to 0.5 multiplied by 4 to the 0.5, and then in brackets x plus 2, and close the brackets, and then we add the 3 at the end there. Now we can more easily identify what the a, k, d, and c variables are, and then of course what the transformations are. So we notice first that our a value is 0.5, and keep in mind that this means that we are vertically compressing by a factor of 0.5. Our k variable is 0.5, and this means that we are horizontally stretching by a factor of 2, because 2 is the reciprocal. And our d value is going to be -2, and that means that we're moving the graph 2 units to the left. And finally, our c value is 3, which means that we move our graph 3 units up. What about the y-intercept? So to find the y-intercept, all we need to do is let x equal 0, and then we're going to solve for y. So when we let x equal 0, we end up getting y is equal to 0.5 multiplied by 4 to the power of 0.5 times 0 plus 1, and then we are going to add 3. And keep in mind that I could have subbed in 0 into this form of the equation or this form. It doesn't make a difference at all. So when I go through the work here, I have 0.5 multiplied by 4 to the 0.5 times 0 plus 1. So let's just go step by step. This gives me 0 plus 1, so that's just going to be 4 to the power of 1 plus 3. And 4 to the power of 1 is quite easy, that's just 4. And then half of 4, we know that that is equal to 2. So 2 plus 3 gives me a total answer of 5. So that means that my y-intercept is 5. And finally, let's look at D to find the horizontal asymptote. So we notice that in this equation, the c value is equal to 3. So that means that our horizontal asymptote will simply be y is equal to 3.